Hey math kids, today we're going to talk about the absolute value function, and once again we're just going to kind of jump in with an example. Okay, we want to look at the absolute value of f, and then we also want to look at f of the absolute value of x. So remember, the absolute value function just turns everything positive. So if it's positive, it does nothing to it. If it's negative, it just makes it positive. So if we were to graph this, the original function, it's just going to go like this. And if we, basically this is saying take the absolute value of all the y values. So this piece is going to stay the same. This piece will stay the same. But this part that has negative y values, those are going to just flip up and become positive. And so this blue one is the graph of that. Now this one, if we have positive x values, they stay the same. So this green piece is all going to stay the same. And then what's going to happen is anything that was negative is kind of forgotten about, and we just repeat what our positive values were. So for example, if we get -1, that's going to spit out the same thing as 1. It's going to spit out the same y value, like that. Okay? Alright, now they want us to look at the absolute value function as a piecewise function. And so here's the piecewise definition. And then they want us to graph the following. Okay. So if we do this, we're going to look at it like this. So if x is less than 0, then f of x is going to equal x minus -x, which is equal to, that would be x plus x, so 2x. And then if x is greater than or equal to 0, then f of x is going to equal x minus x, which is 0. So if we graph that, what's going to happen? It's graphing this part. So when we're less than 0, we do 2x. So if we look at the origin, it's going to be like that. We're going to go down to left 1, connect that, and then for this portion it's just 0, and so right at 0 we're 0, and it's just going to look like that. So that's going to be our function for that one. Let me just erase this a little bit. Okay. Now if x is less than or equal to 0, then we're going to get x less than or equal to 0 is -x, so x times -x is going to give us -x squared. And if x x is greater than or equal to 0, we're going to get x times x, which is x squared. And so if we graph this top part, when we're to the left of 0, we're going to have an upside down parabola. We'd have a circle right there. And then when we're to the right, we're going to have a right side up parabola, but also including 0. So we have something like that. It almost looks like a cubic function, but it's not. Okay, we're going to keep going. So now we have 2x plus 3 in absolute values. And what we're going to do, when we have an absolute value, the entire thing on the inside could be negative, and the entire thing on the inside could be positive. And so what I'm going to do is I'm going to treat it like 2x plus 3 equals 7. And I'm also going to treat it like 2x plus 3 quantity negative equals 7. And we just solve both of these. Distribute the negative. Okay, and just, put the word or in between them. So the answers are x equals 2 or x equals negative 5. Okay, we'll try another one like that. Okay, this one right off the bat, we say no solution, because there's no way to get a negative number out of an absolute value. Okay, 3x plus 2 over 1 minus x, absolute value, equals 4. Okay, once again, absolute value, the insides could be positive or negative and still come out with a positive answer. So we're going to first just write it how it is without the absolute values, and then we're going to think of it as if it were negative. Okay, so on this one, I'm going to break up the fraction. These cancel. 3x plus 2 equals 4 minus 4x. I'm going to add 4x to both sides. Subtract 2. So x equals 2 sevenths. Okay, now over here, I'm going to distribute the negative to the top. I'm going to multiply both sides by 1 minus x. And I'm going to distribute I'm going to add 4x, add 2. So x equals 6 or x equals 2 sevenths. Okay, now we have x plus 1 equals 2x minus 3. Once again, we can think of these like they're both positive or both negative, and it would make them true. So we're just going to think of this like x plus 1 equals 2x minus 3, and then x plus 1 equals negative 2x minus 3. Now, this might seem a little weird because, like, technically it's plus or minus, right? but if they're both positive, we have that. If they're both negative, we could just divide both sides by negative, and they'd both be this. And then if one's positive, one's negative, we could like switch the sides. So it really just comes down to they need the same sign or they need a different sign. And so we actually do have all the possibilities. If you don't believe me, work it out. The 4 different ways you could do it. You could do positive, 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 negative, negative, positive, negative, negative, but you'll see that it will come out the same way. Okay, subtract x. 1 equals x minus 3, add 3, so 4 equals x. Distribute the negative, subtract 3, subtract x, so 2/3 is equal to x. Remember, use the word or. X is 4 or 2/3. Okay, now they want us to solve graphically. So let me get Desmos. Alright, here's Desmos. So we just want to graph both sides. If you go A, B, S, and then do x plus 1 on Desmos, that graphs absolute value. And then x over 2 plus 2. And so we just look at the 2 spots where it crosses and we write down those x values. So it's going to be -2 or 2. Okay? Alright, moving on. Now we're going to do inequalities. Okay, they work basically the same way. So we're going to get 2x minus 1 is less than 3. 2x minus 1, quantity negative, is less than 3. And so we add 1, 2x is less than 4, divide by 2, x is less than 2, and then distribute the negative. -2x plus 1 is less than 3, minus 1, -2x is less than 2, divide by -2, x is less than, no, when you divide by negative, you need to flip the inequality. So if we look at this like on a number line, we have -1, we have 2, this goes this way, this goes this way. We only want where they overlap. And so we're going to say -1 is less than x is less than 2. Okay. Alright, 4 minus x, absolute value, is greater than or equal to 5. 4 minus x is greater than or equal to 5. -4 minus x is greater than or equal to 5. Alright, so we subtract 4 from both sides. -x is greater than or equal to 1. We divide by -1. So x is less than or equal to -1. Notice how I switched the inequality on that one. Distribute a negative. -4 plus x. Add 4. X is greater than or equal to 9. So we look on a number line. -1, 9. And so that's just a situation where we say or.